So like I said, we're going to try and identify the number of solutions a system has without actually solving it. Okay, so like by solving, I mean 1.5, 1.6 will be like the algebraic way of solving things. But on Friday, we like graphed two lines and we saw, okay, does this intersect at one point? Do they have the same slope and are parallel? Do they like, do they have different Y-intercepts sort of thing, right? We were looking at all those things. Those would be examples of like, can I identify from just looking at the M and B values whether or not two lines intersect, okay? Right off the bat, without actually having to solve them, okay? That can be a useful skill if you get kind of a funny answer when you start doing 1.5, 1.6. Because in that moment, you're like, did I do something wrong? Or this is telling me something, right? So 1.5, 1.6 might fall back on, can you determine things in 1.4, okay? Just to help yourself get out of a bit of a hole, right? If you're stuck. Okay, so when we look at this, okay, we're gonna like, it's the same thing as Friday. I got two lines and I'm gonna try and number them 1 and 2, right? And you're gonna like figure out down here, we're just gonna go sequentially down, okay? What the slopes of the lines are. Okay, so what's the slope of the first line? Okay, remember if I were to write y equals mx plus b underneath, all you're doing is matching up if there's a number in front. So when the slope, if I want the slope, I'm looking for the m value, okay, in the first one. So what's the m value in number 1? It's a slope of just, yeah, 2. So it's just 2, okay? It's always the whatever's attached to the x variable, or like, okay, that's the number out front. So m equals 2, which you could rewrite as being 2 over 1, right? Like the rise over run. You're going to go up 2, right 1, up 2, right 1, or down 2, left 1 sort of thing, right? And then in the second one, we're going to have a slope of what? -1, good. Okay, good. So that's implying you can put it over 1 as well. You're going to go down 1, right 1, down 1, right 1. Or you could flip the negative and go up 1, left 1, right? Now, that's good. What are the b values? So the initial, like where the graph's starting. Y-intercepts, right? In the first one, what's the b value? Look, where's the graph start? Just at 1, right? In the first one. And in the second one, we're going to start at 7. Okay, it's a number on the end. Okay? At which point you could go down here and you're going to get the hang of this in the sense that, like, the more of these that you do, and hopefully by now, like after you've done the homework from 1.3, you should be pretty good at graphing the lines, right? So I can go find, I'll do these in 2 different colors again, okay? I'll do the first one in red, okay? So I'm just dealing with the ones, okay? So my y-intercept is 1, and then I'm going to go up to right 1. Okay, and I'm going to explicitly ask, even on today's quiz, I'm going to explicitly ask you to graph the lines or solve a system by graphing. Okay? Okay? And the second one, we said, we're going to do it in blue. It's going to start at 7. I'm going to go find 7. And then I'm going to go down 1, right 1. Down 1, right 1. Okay? And the opposite of that we said was going up 1, left 1. And then from there we're able to identify our point of intersection. Okay? There's one single point of intersection. Okay? That's because you have two different slopes, two different y-intercepts. You get one point of intersection in that instance. Okay? And it might make a little bit more sense as we start to contextualize as we go to the next examples, right? So we're just going to get one solution down here. Okay? Or one point of intersection. Okay? Then on Friday, I also showed you a couple other little tricks, right? Hey, Alden, how are you? So remember, we use the y equals mx plus b method to graph lines, right? We don't necessarily know how to graph things. We could in standard form. We could, but it's maybe not the best way to do it. Could be. Okay? You sometimes get some funny values when you do that, though. That's the only thing. Okay? So what we can do is switch these things around, right? So I just want it y equals mx plus b again. So you're just going to switch. You're going to divide. I'm going to do the first one. Okay, I'm going to divide everything by 3, right? Sorry, I should have left you more room there. Okay. The 3's are going to cancel. We'll do one thing at a time. Okay. And then I can divide everybody by the -1 again. Okay. Which is ultimately going to cancel the negative there. And okay, there's your first equation. Try to get rid of some of this stuff. Okay. Same thing again for number 2. I'm just going to divide everything by 3. Okay. So y is going to equal 2 over 3x minus 3. Okay, and then we can identify from the lines, right? These are the two I'm looking at. We're going to identify from both of them what the slope and y-intercepts are. Okay, and this is where you're going to start to see a pattern. What's the slope in one? It's the number in front of x, 2 over 3. And the slope in the second one, again, 2 over 3. What's that tell you? Right off the bat, what's that tell you? Yeah? Parallel. They're parallel. Right off the bat, they got the same slope. They're like running something like this right off the bat. The second question you have is whether or not they have the same y-intercept, because that's going to determine whether or not they're basically the exact same line. If they have the same y-intercept, then they're going to run right on top of each other. That's your decision point. Okay, if you see the same slope, they're parallel. Okay, so now we can go back here and we're like, okay, well, what are the y-intercepts? Well, they're on the end, right? In the first one, the b value is -2, and in the second one, the b value is -3. So what's that tell us? We don't even really have to graph the line, but we will. Okay. So in the first one, okay, I'll do it in black. We're going to start at -2, and we're going to go a slope of 2 over 3, up to right 3, up to right 3. Okay, you get the idea. And in the second one, I have a y-intercept of -3. Sorry, the line's not the best. Okay. Second one, we're going to go find -3. These are really close. I should have made these different, but that's okay. Same thing, up to 1, 2, 1, 2, 3. Okay, you guys might be able to get a little closer than I can. Are those ever going to touch? So there's no point of intersection, therefore you get no solutions. Okay? They're just both, they're lines that go on both directions forever. They have the same slope, they're never going to cross. Ergo, you don't get any point of intersection. Okay? The last one we could do, again, we're going to have an issue with this, the way it's written. So we can go, I'm just going to try to get y by itself. Okay, so negative 2y is equal to negative 4x plus 6. And I can divide both sides by negative 2. And my equation is going to become y equals negative 2x minus 3. Okay, I'm going to do the same thing in the second one. I'm going to try to get y by itself. So I'm going to get 3y is equal to 6x minus 9. Okay, remember all I'm doing, I'm just, sorry for those of you that weren't here, I'm just adding 2y to each side, okay? And in this one I subtracted 9 from both sides. Okay, yeah, Rita?
I'm pretty sure the first equation is just 2x, because kind of you forgot to write negative 2 under negative 4.
Oh, sorry. You're right, sorry. So that makes a positive, right? Is that what you're saying? Sorry. Okay, there's one equation. It's easy to make a little sign error. That's important because then it changes the direction of the line, right? So you get a different answer. Okay. So at this one, divide both sides by 3, everything. Okay. And the equation becomes y equals 2x minus 3. Surprise, surprise, they're the same line. What does that mean? They're the same line. How many solutions do you get? If I were to go down here and plot this line, okay, y-intercept of negative 2, then I have a slope of 2 over 1. So I'm going to go up 2, right 1. Okay, and I'm going to plot those. That's the first line. It just so happens in this question, the second line is the exact same. Right? How many points of intersection are there on those things? Those are your 3 instances, and that's it. Okay? Either the slope and the y-intercept don't match, in which case you get 1 point of intersection somewhere. The second instance is you can have matching slopes but different y-intercepts, then the lines are parallel. And the third one is they're exact same line, in which instance you get infinite solutions because they're crossing each other basically always, right? Does that make sense? Any questions? So it's good this worked out in this order because we're trying to reinforce you graphing lines and understanding what the point of intersection is, okay? Some of us need that extra review of graphing lines too, okay? Down here we'll summarize everything too, okay? So I'm going to put it into text. Basically write the same thing twice, okay? So we don't really, I'm not going to make you write anything here. Just ignore that. Let's go down to the, flip the page over. This will summarize it all for you, okay? So one solution if the linear equations have okay, if they have different slopes, okay, which basically means the lines intersect somewhere, Okay. You're going to have no solutions if the two linear equations have what?
Same slope, different than Y-intercept.
Good. Okay. Same slope. Different slope. Oh, sorry. Y-intercept. Okay, remember, I'll write underneath these just in case anybody needs them. Different slopes. That'll be M. Same slope. M, B. Okay. And then under the, in the second part there of 2, the lines are considered to be, oh, here we go. Can't remember how to spell parallel. 2 R's and 2 L's. It's a tricky one.
I don't know. I don't have it right now.
What's that?
I don't even know.
It's 2 R's and 2 L's, I think. I always mess it up.
I'm pretty sure it's one. I usually write
You guys can Google it later. Elda, do you know?
I think it's P-A-R-A-L-L-E-L.
I don't think there's two.
Okay, we could look after. Okay, and the last one, you have an infinite number of solutions if the two linear equations have what? And then, i.e., the lines are the same. Okay? Any questions? Okay, so hopefully that's like a good, I don't know, I think that's a good lead into what we're doing today. And it pulls in what we did Friday. It's a good like pivot point, I think. Okay.